So I'm sure many of you have heard about the Ridgecrest Quake and whatnot. And I'd like to say that, yes, it is definitely a bit exaggerated, especially in the case of what LA Times, I think, did a publication, National Geographic did a publication, and it's a bit much. Some of the wording, I think, is verbose, is misleading to some extent. So I want you to be aware of what's actually happening with that. So again, Dr. Lucy Jones here quoted or tweeted, and I quote, context, the chance of a San Andreas quake is up slightly if, or a Garlock quake happens because of Ridgecrest, and if this model is correct. So we have to take into account at least two ifs. So you have to consider this is a one of many papers that are published in the geosciences. And it just happens to be one that newspapers can hook onto, be like, oh my God, the San Andreas has got a 3% more chance it's gonna go for sure. No. That's not what that paper is saying at all. And if they actually read the fucking paper, they would know that. Yeah, Seismological Society of America. Bulletin of Seismological Society of America is the original paper from which this comes from. Toda and Stein are the authors. And it was very recently, July 14th. It was very, very recently. Anyway, let's get her link in chat for you guys so you can follow this geologist if you so wish. But I really, really enjoy the geoscience community on Twitter because they often clear up things like this. So, like the original tweet, new study suggests a Ridgecrest earthquake last year upped the chance of big San Andreas earthquake. I don't know where this came from. This is just one plausible scenario. John Schulis, LA Times, apparently made this. So some guy in the LA Times made this. Doesn't look like a geologist actually made this. So that's kind of disconcerting, I'm not gonna lie. Okay, Lucy Jones was actually quoted. So Dr. Lucy Jones was actually quoted as elegant science, but out of that. See, this is where they started to go right. Seismologist Lucy Jones, who did not play a role in a report released Monday, called this study elegant science, but added that its conclusions are not confirmed, but it's not yet proven. So they do a little bit, they do redeem themselves a bit, but it's not yet proven. That said, Jones said the government officials in California should prepare for a scenario in which earthquake occurs that immediately raises the large risk of... But this is... Okay. I don't know exactly... I wish that there was an actual quote because I don't know how this was worded based off what she said. Okay, so here's Stein, the actual author of the paper, saying, now you can think of Ridgecrest earthquakes as being so far from greater LA and that it's nearly harmless. But the problem is, Ridgecrest earthquake brought about the Garlock fault closer to rupture. Now, he's making that a definitive statement. I don't personally like that. That's making a seriously definitive assumption. The Ridgecrest earthquake brought the Garlock fault closer to rupture. Now, if it ruptures, they've collected a few different articles, I think, but they haven't... Oh, yeah, I wanted to show you. They didn't actually link the paper. They didn't link the paper at all. They referred to their other papers, and they quoted a few scientists, but they didn't link the original publication at all. But I found a similar story in the National Geographic that did. So no, you can't predict earthquakes. So I found the original article, right? And this is it. This is the article that was used in National Geographic, LA Times, and anywhere else that decided to do a clickbait-like article. If you'd like to check it out, there is the link for yourself. Highly recommend. I don't think we could either. So we first explore a series of retrospective earthquake interactions in Southern California. There are four over magnitude 7 shocks in the past 150 years brought by the Ridgecrest fault. So there was a 34-hour time span between the 6.4 and the 7.1 that recently occurred. Okay, these results motivate our introduction of forecasts of future seismicity. So they are working on it. It hasn't been conclusive. And they even admit that. Most attempts to forecast aftershocks use statistical decay models or Coulomb stress transfer. Statistical approaches require simplifying assumptions about spatial distributions or aftershocks and their decay. Coulomb models make simplifying assumptions about the geometry of the surrounding faults, which we seek to here to remove. We perform a rate state implementation of the Coulomb stress change on focal mechanisms to capture fault complexity. So they're using Coulomb stress, which is the Coulomb model, but I think they might have changed it a bit. So they're using an older model and also maybe tweaking it just a bit to model this. And I want to show you. This is one of their images. They're actually talking about several different earthquakes. They're talking about earthquakes all the way back into 1872 in this area of California. These little tiny pink donuts, they are various earthquakes that have occurred, and they, for the most part, show areas of what's called stress or built-up pressure. And they're suggesting that because of that, those build-ups are eventually going to trigger a bigger fault on the Garlock, which is right here. Here. So this is the Garlock fault at depth. This is the Panamint Valley Fault, the Sierra Nevada Frontal Fault. So this is the eastern side of the Sierras. And then the Little Lake Fault Zone right here is actually pretty close to the Sierras. But it is north of the Garlock Fault. Lake Isabella Fault is the one that goes under the dam, by the way, that we went to. White Wolf Fault I haven't studied much about. But this is one of the things I actually wanted to show you. I know it's super simple, but it's very, very true. So this is kind of an old school way, or a way in which it would be ideal to study a fault and the plane on which it might slip within the ground. But it's not. This isn't realistic. This is a bunch of crap buried at weird angles to one another, mixed in with a bunch of water. Maybe some of it's unconsolidated. Maybe there's new minerals precipitating in and filling old pore spaces. It's crazy complex. And we can only image so far into it. So trying to say that you can predict or forecast earthquakes is, at this point in what we have technologically, is just, it's not happening. We're not there yet. We're not there yet. Well, I mean, they're giving a probability within the next year. But again, this is all off of modeling. So that's assuming this modeling is absolutely right. The Ridgecrest affords a unique opportunity to probe earthquake interaction. And that's another thing, too. You have to understand that they're also only looking at this area. And they're also only looking at this area within the last 150 years. The farther back we go in history, the less detailed information we can get on those fault planes that have slipped. There is even a possibility that we're not even accounting for one. Maybe one has been completely eroded and weathered, and we can't even see any signs or pieces of information suggesting that there was another one since 1872 that isn't being accounted for in this paper. So you have to consider quite a bit. And they did an excellent job with their work. I'm not saying that they didn't. But I'm saying that you can't take these kinds of papers and say, oh, that's it for sure for reals, because they even admit, hey, this is a probability, this is an analysis, this is using modeling. We are hoping that this will work for future forecasting. But they're not saying that it is definitively forecasting. And then when LA Times and National Geographic and other major media got a hold of it, well, they worded it in such a way that's going to generate clicks. So the point of this, TLDR, moral of the story, try, if you can, to find the original paper. I know some of this is jargon-filled, and I'm not a seismologist. There's stuff in this paper I don't understand. Don't get me wrong. If this was on the geochem side of things, I'd probably understand this way better. But the seismology and the geophysics isn't technically my field. I love it, and I'm always going to learn more about it, but you have to understand that. So don't feel like, oh my gosh, I can't understand all these words. That's okay. Just kind of skim through the intro, the conclusion, do the best that you can, look at some of the diagrams, try to interpret them to the best of your ability, but understand that when they talk about modeling and they talk about statistics and there's actual papers that contradict them, right? And there are a few different publications out there suggesting what's going on with the Ridgecrest quakes specifically. And this isn't the only situation like this. There are many others around the world. Take it with a grain of salt and understand that these mainstream medias are trying to generate the clickbait and that's, they're a company, right? They're trying to make money. Unfortunately, that's how it is. So share the information if you can, and make sure that at least you understand. And I feel that most of you do.